Anybody?
Ma'am, like the Laplace transform after applying, it becomes equation of S domain.
This is the circuit in S domain. This is the circuit in time domain. Okay. Now, this is this circuit. In this circuit, the initial, what was the initial condition that is given in the problem? What was that? See the last class problem.
Ma'am, at t is equals to 0, switch
T
is
is equal
open.
to
0 minus is 0 minus is equals to 5 ampere.
no. That is that current at T is equal to 0. Okay, 0 minus. What is the current that is given in the problem? I think that is, what was that?
Ma'am, 3 ampere.
3 ampere. Okay. So at this is the initial condition of this problem that is already mentioned. 3 ampere is the initially bit is connected. Okay. So the 3 ampere is the current, steady state current flowing through that circuit. That is all mentioned in the problem. Yes or no?
Yes, ma'am.
Okay. So this is the S domain circuit, right? So since the initial condition is this, we have to put this 3 here, minus plus. If initial condition is 0, that case you can neglect this part. You can neglect this part. So depending on the initial condition, we can draw the S domain circuit from the time domain. If initial conditions are 0, no capacitance surge, no current flowing through it was initially open, we are going to close, that case you can neglect this part. Okay, so based on that, now we are going to deduce the expression for RLC series circuit. Using Laplace transform. Okay. First, you draw the time domain. This is time domain. Minus, okay, T is equal to 0, R, L, C. So this is the V. Let us consider RLC series circuit as shown in figure in time domain. Now, draw S domain circuit. In this case, initially the circuit open, so no flow of current. That's why this part that plus minus 3 ampere that is already done for the last class problem, that part can be neglected. SL. Okay, this is what in
1 by C.
CS. Okay, so this part R, right? And this is what P by S. T is equal to 0. So this is what circuit? This is the S domain circuit. Here the current is IT. In this case, the current is IS. So from time domain, we can draw the S domain circuit. Depending on the initial condition, we can draw this. If the initial condition is there, that case we have instead along with this another part is that is what is that plus minus 3 ampere or plus minus 2. So that part should be there. Okay, since in this case, since the initial condition is 0, so we can neglect that part. Now, from the S domain circuit, we can write IS is equal to V by S. Directly write R plus SL plus 1 by CS. Very simple, okay? Now, V by L S square plus R by L S plus 1 by LC. Yes or no?
Yes, ma'am.
Okay. Now, these can be simplified like this. S1, S minus S2. Okay. So this is equal to A by S minus S1 plus B by S minus S2. So two roots are there in this equation. So S1, S2, root of the equation what is the equation? This is plus R by LS plus 1 by LC. Okay. So can you tell me this S1 equal to what?
Minus R by L.
Minus
Minus
R by
R L.
twice L.
Wait,
Okay.
Yes.
Then
Plus
minus. So for one root that is plus, okay. For second root that should be minus. Okay. So R by twice L whole square minus 1 by LC. This is the one root. The second root R by twice L minus. So R by twice L whole square minus 1 by LC. So this is, it can be written alpha plus beta. You can assume this alpha minus beta. So from same way, we have two roots for this type of circuit in S domain using Laplace. Okay. Now, B is equal to B by L S minus S1. This is what? S is equal to S2. Okay. So this is B. And where? What is A? A is equal to, same way we can write A is equal to V by L S1 minus S2 positive. By putting the second condition, we'll get A. So after that, what to do?
Equation of I of S.
Equation of I of S. So this is equal to V by L S1 minus S2. Okay. So 1 by S minus S1 minus 1 by S minus S2. So this is the equation. So next, taking inverse of Laplace. Now taking Laplace inverse, we get IT is equal to V by L S1 minus S2. This is what?
E to the power minus S1.
E to the power
S1t.
S1t, not minus.
S1.
Okay. Minus e to the power S2t. So this is the equation in time domain for the RLC series circuit. Now, condition when R by twice L is greater than 1 by LC over them, write down S1 and S2 real and unequal. Okay. So this is condition 1. Now write down condition 2. The expression for IT in that case, that's the same. Same you can write from this time domain expression, same expression you can write here. Just for the time being, you just put the condition for R by twice L equal to LC. You write down the condition. Then go for the third condition. Less than 1 by LC. And write down what is that? This is damping or over dam, under dam? Third case?
Under them.
Under dam. Write down under damping, S1 and S2, conjugate complex. Okay. Now, problem. Write down problem. Capacitor has initial charge. Capacitor has initial charge of 100 microcoulomb at t is equal to 0. Capacitor has initial charge of 100 microcoulomb at t is equal to 0. Switch is closed at t is equal to 0 when switch is closed. When switch is closed, write down, find the expression for current. When switch is closed, find the expression for current. So this is the circuit. So this is time domain or S domain?
Ma'am, time.
Time domain.
It's the time domain. Okay. So you can solve this problem without drawing the S domain circuit. You can write down the equation. Initial condition is there. In this case, the initial condition, what is that? That 100 microcoulomb charge is there. That is the initial condition in this problem. That is given in the problem. That is not 0. Okay. So in this particular problem, the initial condition, what is that? 100 microcoulomb is given. Okay. Now, if you want to solve this problem using in the Laplace transform, you can first, two ways you can solve this. You can draw the Laplace S domain circuit. After that, you can directly write the expression for IS. That is one way. Just now we have done that. First, you draw the S domain circuit, and from the S domain circuit, you can directly write IS equal to what expression? Or from this circuit, you can write the KVL equation. That is one way. The KVL, after writing the KVL equation, try to apply Laplace transform. You will get the expression for IS. So what we need the IS expression? Yes or no?
Yes, ma'am.
So to write the IS expression, two women, then you put Laplace transform, you will get IS. That is one way. Or the second option, what is that? You convert this into S domain circuit. That case, you can directly write IS from that figure. So that is little bit complicated because the initial condition is given. Just now we have deduced the expression for RL circuit. That case, the initial condition is not there. So we can directly write. Directly convert that circuit easily. But if the initial condition is there, so you have to consider that part in this case, capacitance case. So capacitance 1 by CS. So 1 by CS, that means what? C means this, 10. Okay. Along with that, some another factor will come while you are going to transform this time domain into, because the initial condition is there. In your WhatsApp, I have already given that page, photograph of that page. If you see that case, that in case of capacitance, what will be the expression? In case of inductance, what will be this? If the initial conditions are there, that is, everything is there at that single page. Okay? Any doubt? Any question? Kwa? So first, you see the diagram. That is always in time domain. Okay. Now we are going to solve this problem using Laplace transform. So to apply Laplace transform, first you write down the KVL equation in time domain. Then you apply Laplace transform. I think that will be better. It takes time. That means because the number of steps will be more in this case. Or you draw the S domain directly, but that should be correct. And then you can write it. That's IS. কোৱা বুজি পাইছা নাই কোৱাচোন কি কৈছো মই
Yes, ma'am.
Yes, ma'am.
বুজি পাইছা any doubt any question কোৱা
Ma'am, by applying Laplace, ma'am, we get the expression for Vs, then we can do for Is, right?
no Vs no expression for Vs means see this
Ma'am,
is
capacitor voltage.
the capacitor we have to find out this capacitor voltage you can find out no C is there C দিয়া আছে Q দিয়া আছে
Q is equal to 0.
we can calculate that capacitor voltage
Yes, ma'am.
So after drawing this in S domain you can directly put so তুমি যদি ভালকে বুজিছা you can do that কারণ প্লাস মাইনাস এর গন্ডগোল হয়ে যাব two way we can solve one after drawing the S domain circuit or first you write down the expression for KVL equation in time domain then you make it S domain KVL equation in time domain that will be better I think okay so try to solve this problem say what will be the initial condition at t is equal to 0 minus VC this is how much
V naught 10 volt.
10 volt Q by C yes or no Q by C so 100 into 10 to the power minus 6 again 10 into 10 to the power minus 6 this is 100 volt because initial condition is not 0 in this problem those switch is open but initial condition is not 0 already surge capacitance okay now T is equal to 0 plus just switch it on so VC 0 plus in that case also 10 volt okay now I C 0 plus this is equal to what
This will be 0.
no capacitor is charged no so what is that
Ma'am, C dvdt.
no so বুঝি পাইছাম নাই
Yes, ma'am. Yes, ma'am.
is it okay
Yes, ma'am.
Yes, ma'am.
very মানে মাইনুট হেৰি কিছুমান থাকিব তাৰমানে ভুল হ'ব so you should be very careful এইটো যদি ভুল হৈ যায় গোটেই প্ৰব্লেম ৰং so this initial condition analysis this part is very very important নহলে তোমাৰ সব ভুল হৈ যাব so any question regarding this anybody কোৱা বুজি পাইছা নাই কোৱা
Yes, ma'am.
তুমি বুজি পাইছা তোমাৰ কথা বুজি পাইছো বাকি বিলাকে তো চুপচাপ আছে
Ma'am, যদি ইন্ডাক্টেন্স এটা সিরিজত লগোৱা হয় IC0 প্লাস সেম কন্ডিশনে হ'ব নেকি
না ইন্ডাকশন রিলেটেড ইনিশিয়াল কন্ডিশনটো যদি দিয়া থাকে তেতিয়া কথাটো হেতু থাকিব জেনাৰেলি কি হয় স্টেডি স্টেট কন্ডিশনত ইন্ডাক্টৰৰ কি হয় VL = 0 হৈ যায়
Yes, ma'am.
সেইকাৰণে তাত সেই বস্তুটো নাহে কেপাচিটেঞ্চত আহিব কেপাচিটেঞ্চত তুমি চোৱা VC is not 0 ভ্যালু থাকে IC 0 হৈ থাকে steady
Yes.
state কেপাচিটেন্সটো বাঢ়ি গৈ থাকে না ভোল্টেজটো কিন্তু ইন্ডাক্টেন্সত কত কি হয় steady state condition inductance in case of inductive VL is equal to 0 হয়নে কিন্তু
Yes.
Yes, ma'am.
কারেন্টটো
কারেন্টটো ইনস্টেন্টেনিয়াছলি চেঞ্জ হৈ যায়
না তুমি নিজে নিজে অকমান এখিনি পাৰ্ট চোৱা মই কিমান ইনপুট দিব পাৰিম তুমি যদি নিজে সেলফ স্টাডি কম্পোনেন্টটো যদি তোমাৰ নাথাকে সেলফ এনালাইসিস পাৰ্টটো যদি নাথাকে ইউজলেস হৈ যাব this is the analysis হয়নে নহয় এইটো so this is situation কি হ'ব so এনেকুৱা বেলেগ বেলেগ প্ৰবলেম আছে you try to solve those problem হ'ব বস্তুটো each প্ৰত্যেকটো মানে every problem has different condition every problem এটা problem similarity নাথাকা and there are so many books ক'ৰ পৰা আহি যায় তুমি কমনো পেলাব নোৱাৰিবা এইটো প্ৰবলেম একদম সিধা সিধি এইটো প্ৰবলেমে আহি যাব নহব 6-7 books are there so different book has different problem different condition different initial status for every problem so try to develop your concept that is very important যদি সেইটো হৈ যায় you can solve the problem easily no issue okay now from now when switch is closed by applying Kirchhoff voltage law we'll get RIT plus 1 by IC IT dt is equal to what
100 full.
100 okay now R IT R DI dt differentiate this plus 1 by C IT is equal to 0. Now taking Laplace transform R SIS minus IC 0 plus IS by C is equal to 0. Yes or no?
Yes, ma'am.
So initial condition যদি তোমাৰ নাজানা তেতিয়াহলে হ'ব নেকি এইটো নহ'ব ইয়াতে গ'ল problem শেষ So if you can draw the S-domain circuit, you can directly write this equation. So I think that this way will be better. So you will get the answer this IS, then you can make it convert it in time domain. So what is the expression for time domain? IT is equal to what?
E to the power minus 1 by RC.
CT. Only?
Yeah.
So simple. So it has only one root, so we can directly write. If it has two roots, you have to go for A plus B. That condition has to be applied. 2 roots in case of 2 roots. So that will come if the circuit contains 3 parameters R, L, C. তেতিয়া 2 roots concept to আহিব alpha and beta. S1 and S2 থাকিব in that case. So in case of series RLC circuit, we have 2 roots. By putting the condition, we can find out the value of the numerical value of the roots, and we can write down the equation. So for one particular circuit, there will be one equation depending on the condition of the roots. Okay. Next. Okay. In the series RLC circuit, write down problem. In the series RLC circuit, shown in figure, comma, there is no initial surge on the capacitor. That is all clearly mentioned. There is no initial surge on the capacitor. Okay. If the switch S is closed, at t equal to 0, determine the resulting current. Okay. Then this is the circuit given in the problem. Now determine the resulting current. Hello? মই পিছত লগ কৰি আছো দেই মই ক্লাছত আছো Okay. Now from this circuit, can you draw S domain?
Yes, ma'am.
Draw the S domain. So since there is no initial condition, you can directly draw this S domain circuit. So this is 50 volt plus minus, and this one 2. Okay. And this is what?
S.
S, simple S, because 1 Henry. And this part?
2 by S.
1 by 0.
1 by 0.5.
S1.5 S. Okay. And regarding the voltage, S. Okay. And for 2 ohm resistance?
2 only.
Only 2. Okay. So Now, here IS, okay? This is IT. This is time domain. This is S domain. Now, you can write IS. Directly write. V by S 2 plus S plus
2 by S.
0.5 S. Okay. So simplify this by putting all the value. You can simplify this expression 50 S square plus twice S plus 2. Okay. Now 50 S plus 1 root plus 1. Yes or no? Swa?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. Now this is IS, right? So in time domain, this is equal to what? Inverse of Laplace. This is equal to what? 50 e to the power minus t sine t. Yes or no? Swa.
Yes, ma'am.
This is the mathematical part. Laplace transform of this. So some expression inverse of Laplace. I have to remember these things. This is equal to this. Okay. So this is the very easy problem. You can directly write. No KVL equation in this case. Okay. So next problem to write down. Consider a series RLC circuit. Consider a series RLC circuit with capacitor initially surged to voltage 1 volt as indicated in the figure. Initially surged to voltage 1 volt as indicated in the figure. Find the expression for IT, current. Current, I, within bracket, T. Also draw the S domain circuit. Also draw the S domain circuit. So given circuit, this. So in this case, the capacitor is initially charged with 1 volt. Now what will be the initial condition? T is equal to 0 minus IL 0 minus, this is equal to what? 0. VC 0 minus 1 volt. Yes or no? No.
Yes, sir.
Yes.
Asam na ki hole khotna to etia. Yeah, there is no source in this circuit. Again, T is equal to 0 plus IL 0 plus, this is equal to also 0, and VC 0 plus, this is equal to 1 volt. Now you can write KVL equation. RIT plus L DIT dt plus 1 by C IT dt is equal to 1. Yes or no?
Yes, ma'am.
Okay. Now, simplify this. Try to find out the expression for IS. What is that? Tell me. IS equal to what?
R
IS is equal to
R plus
check kora. Ito paisa na nai. Ito ভুল legi mo sabade check korasun. You got it? Is it correct? বুঝছে না একটু ভুল হচ্ছে নাকি একটু পাইছা না
Yes, ma'am.
কারেক্ট হচ্ছে না এক্সপ্রেশনটা
Yes, ma'am. Yes, ma'am.
Okay, so from this expression again, same way we can write in what is your question? You see the question first. Expression for current. That means always try to express the current in time domain. So Laplace inverse of Is, that is equal to IT. So this is equal to e to the power minus t sine t ampere. So this is the answer. And the next part of the problem, what is that? What is that?
S domain circuit.
S domain circuit. Also draw the S domain circuit. So how to draw the S domain circuit? You can make it close while drawing this S domain circuit. So in this case, the initial condition is there. So along with this, again, R, okay? So this is the S domain circuit for a given problem. হৈছে নাই?
হৈছে না?
হৈছে. So draw the S domain circuit, এটা এইটো draw কৰিব লাগিব. আৰু নহলে if you can draw at the very beginning, you can directly write this expression. এই expression ইয়াৰ পৰা মিলে নেমিলে চাই ল'বাচোন. This expression, have you seen this cursor? Is it visible?
Yes, ma'am.
Mouse cursor, okay. So you can directly write this expression from this figure. So try to analyze this part also. If you want, you can do that. So can you give one class before puja at any time tomorrow, so that this chapter will can be finished. I need one class, maybe 40 minutes, not more than that. পাৰিবা নেকি কালি কোনটো টাইমত ল'ম কোৱাচোন ইভিনিং ল'ম শেষ হৈ যাব এইটো চেপ্টাৰ তাৰপিছত next week you're free, no class. So at what time? 7:30 evening? Okay. So confirm me today itself. Okay. So don't worry, I'll take only 40 minutes, 45 minutes. So these are all the DC supply. Yes or no? This problem having on DC supply, this is source. Okay. What will be the situation with AC?
মেম
Yes?
মেম মোৰ এটা সৰু এটা ডাউট আছিল এই
কি
ওপৰ
doubt?
কুৱেশ্যন এটা
কি doubt?
মানে আগৰ কুৱেশ্যন এটা আছিলে য'ত কেপেচিটাৰ এটা আছিলে আৰু ৰেজিষ্টাৰ এটা আছিলে
কোনটো?
য'ত 0+ আমি ওলাইছিলো আৰু ওপৰত আছে মানে অলপমান মেম এইটো আৰু অলপ ওপৰত আৰু ওপৰত মেম এইটো IC0 পজিটিভ যোনটো আছে মেম তাত 100 -10 হ'ব লাগিছিল চাগে সেইটো কি
উল্টা হেৰিটো চোৱা প্লাছ মাইনাছৰ কাৰণে